Hello, ladies and gentlemen. The purpose of this video is to finish up some of that vocabulary that we didn't get to in class to make sure that you have the basic foundation here before we continue on in our geometry journey. So let's take a look at that third vocab chart that you have. We're going to place this one in your notes. It should be glued in. You have an extra little piece off to the side there that's going to be folded up and not glued down, but we're going to have these three columns actually physically glued down in your notes, and then you'll have like sort of a little flap there that you fold over to see the next two words. Okay, let's start with the column that says lines can be. Lines can be parallel, they could be perpendicular, they can be intersecting, and they could be what's called skew. So first let's review ourselves with this idea of being parallel. Parallel means that they're in the same plane, but they never cross. So you graphed parallel lines last year. You talked about parallel lines in Algebra 1. You talked about them never intersecting, never to make that solution point for a system of equations. The same sort of thing applies in geometry. You know parallel, you've seen it before. We have two lines here. They're on the same flat surface or the same plane, and they never cross, therefore they're parallel. Now lines that do cross are intersecting, but lines that are perpendicular are lines that are in the same plane and cross to make 90 degrees. So we're looking for more than just the lines to cross or to touch each other or to intersect. We want them to make a special right angle there in the corner. And you see in my diagram here, that right angle will be marked with a little box or 90 written there. That's telling you that those lines are perpendicular. They cross to make what's known as 90 degrees. Now, if they don't make 90 degrees there when they cross, then we call them intersecting lines. They are still in the same plane and they cross, but there's nothing special about that angle that they make when they cross there, okay? It could be 100 degrees, it could be 72 degrees, who knows? As long as they're not making 90, we just call them intersecting. Now, skew lines might be new to you. Skew lines are lines that are in a different plane. Now, it's hard to draw lines in a different plane on your flat piece of paper in your notes because your notes book paper itself is a plane. So let's think about lines or drawing some lines like in a three-dimensional picture, like in a cube, if you will. There's a bunch of planes making up a cube. Lots of flat surfaces there making up a cube. Now, skew lines are ones that are in a different plane and will never cross. Because they're in three-dimensional space, it's easier to show now on your diagram here what skew would be. So let's say I take this back line here on my top part of my box, and I extend that one on and on forever. Now I could also extend one of the lines on the bottom of the box, let's say this one, on and on forever. Now imagine and remember this is in 3D space. Those lines are never ever going to touch each other because the bottom of edge of a box, even if I extend it out, isn't going to touch that top end of that box. They have some cardboard in between, if you will. So skew is best drawn by thinking about those different planes, and I always go to a three-dimensional box to help make that diagram a little bit easier to understand. Now, just like lines, planes themselves can be special. So planes could be parallel, like this picture. Remember, parallel planes would be just like parallel lines. They don't intersect, they don't touch. Now, planes could also be perpendicular. Here, planes are touching, and they're going to touch to make that 90 degrees that we've been talking about. And lastly, planes can be just straight old intersecting like this, just plain old intersecting. Look at this. I mean, no 90-degree corners, nothing too special, pages in a book kind of held sideways there. They're not making 90 degrees, but they are intersecting each other. Now, intersections themselves, let's take a look at. So when two lines intersect each other, like these two lines in this picture, what do we know about that intersection? Well, because lines have to be straight, and because lines have to have arrows on both ends like this, guys, and be straight, that means two lines are always going to intersect at a single point there. That point, you can see right there, I put a little red dot on it. That point is the intersection point. Again, in Algebra 1, you found in the solution point or the intersection point to systems of equations all the time. Now, planes, when they intersect, it's a little different. If I were to look at two planes here and I want to know where do they touch in a lot of different places, not a single point like a line, because planes have edges. They touch all along an edge, so they intersect in a line, not just a single point. So those planes all come together and touch at that middle line right there. That's their intersection. So it's a little different when we're talking about three-dimensional things rather than these two-dimensional lines that you were graphing last year. Three-dimensional pictures, to read that, remember that those planes intersect in a whole line, not just a single point. And now if we flip the flap over, you should see these two words, collinear and coplanar. Collinear and coplanar are two words that come up a lot in geometry. Collinear means together, like co-workers, your colleagues. The CO means together. Collinear means together on a line. So we're talking about points or things that are together on a line. In this case, we would be talking about points. So in this picture, we're saying, what are the points that are on the same line? Now, there are lots of lines going on here, so there are a lot of answers to that question. But if I wanted to name 3 points that are on the same line, I would have to look for those 3 capital letters that signify points that are on a line. So one example is T, S, and R there on the bottom of that diagram. T, S, and R are collinear points because they're all on that bottom line down there. SQV would have been another option. UPV on top, another option. Any 3 points that are together on a straight line. Coplanar is the same idea. Coplanar is what's together on the same plane. So I look at a complicated picture like this. There's a lot going on, right? There's points, there's some segments I see, there's like lots of different, 2 planes here looks like intersecting, like a light blue and a dark blue here, or dark gray. And there's some points not on the plane. So if I wanted to say what is coplanar, you could say point C, D, A, and E are all coplanar. If you look in this diagram, C, D, A, and E are all on that like flat horizontal plane. You could also, you could also list like D, A, and F are coplanar. You would want to be careful because H and I are not on the same plane with anybody. So you'd want to be careful of that whole idea that coplanar means together on the same plane with everybody else, okay? Thank you for filling out this last graphic organizer here of all of our vocabulary, and I want to thank you for taking good notes.